Hi, welcome back. Hearty welcome to you. We are solving some examples by using Gauss-Jordan method in matrices to find out the solution of simultaneous linear equations. We have some linear equations here. We have to solve them. X plus y plus z equal to 9. Let's put down the augmented matrix first. How it looks like. So x plus y plus z equal to 1. So can I say 1, 1, 1. 2x plus 2y plus 3z equal to 6. That is 2x, 2y, 3z or 3z, 6. You have x plus 4y plus 9z, 1, 4, 9, 3. Okay, let's go here now. This is our matrix whatever is given to us. First thing what I have to make sure, make A11 as 1. It is already there. So I can just go and tick mark it. Okay, now what I have to do on this? Now I have to apply. I have to using A1 make A21, A31 as zeros. Using A1 because this is 1. Now I have to make this element as 0. So I can write it as 2 minus 2, right? That means I have to apply transformation and I have to change R2 and R3 respectively. So I will say first R2 is assigned. R2 value is 2 in the first column. Here I have 2. So I will say R2 minus 2 into R1. That will make sure that the first element of second row is 0. Similarly, for third row first element, I will say just R3 minus R1 because 1 minus 1 is 0. Similarly, I will say R3 is assigned R3 minus R1. Now let us see what happens. Now what will happen? The first row, since you are operating on R1, it will stay as it is 1, 1, 1 and 1. Okay. Next, R2 is assigned R2 minus 2R1. That is nothing but 2 minus 2, 0. I also have 2 minus 2. That's also 0. Okay. Then you have R2 minus 2R1. That's nothing but 1. And 6 minus 2, that's nothing but equal to 4. Okay, right. Now what else you want? I want R3 minus R1. If I do 1 minus 1 is 0. Similarly 4 minus 1 is 3. 9 minus 1 is 8. That's nothing but R3 minus R1, that's nothing but 9 minus 1 is 8 and 3 minus 1 equal to 2. Okay. Now you can see here you got 0, 0, 1 and 4. That means now you know what you can do? You can interchange the rows as needed because it's not going to change anything. So what I will do, I will make it as 1, 1, 1, 1. I will get this 0, 3, 8, 2 to the second row and make it as 0, 0, 1 and 4. Now you can see my Z value is already there. Okay. So it's just a bonus for us that when we try to make A11 as A1, we try to make A21, A31 as zeros, we got A32 also. Okay, now only the thing what else is left out is A23. This I have to make it as 0. For that what I will do? Okay. Now I have to make 0, 0, 1, 0, 1, 0. That means I have to make this element as 0. Now my focus is on this one. Now how to make it? Now remember always you have to apply the row transformation with the row where you have zeros so that you will not change the values, existing values. That is very important. Okay, right. So what I will do, I will write, I have to make R2 transform. So I'll say R2 is assigned R2 minus 8R3. So that 8 minus 1 into 8. 8 minus 8 is 0. So can I do that? If I do that, what happens? if I do that, what I will get? I will have R11 as it is 1, 1, 1, 1. I have the third row fixed 0, 0, 1, 4. Now in the second row I will have 0, R2 minus 8R3 will be 3 only here. I will have 8 minus 8, 0, and I will have 2 minus 8 into 4. 2 minus 8 into 4, that is 2 minus 32. That's nothing but equal to minus, that's nothing but equal to minus 30. Okay, right. Now you can see 3 minus 30, I can take 3 out. Okay, now you can see that I have 1, 1, 1, 1. I have 0, 1, 0, minus 10. I have 0, 0, 1 and 4. See how simple it is. The whole key lies on where you are doing the transformations, how you are going through them. Any problem is damn easy. You don't need to do 10 or 15 steps. You can do it very easily once you understand the logic that whatever you are doing the row transformations should not cancel out your zeros and make them as non-zeros again. If you are able to catch that, then it is perfect. Very simple to do. Okay, now what else is left out? I have to get first row elements. That's nothing but A12, A13 as zeros. Now it is very simple. I can do R1 is assigned R1 minus R2, and also I can do R1 is assigned R1 minus R3, so that I can get them. Let me do it here. Okay, first I will say R1 is assigned R1 minus R2. Now what happens? R2 and R3 will be as it is. They will not change. We know that. So I will have 2 and 3 fixed, 0, 1, 0 and minus 10, that is my y value, and 0, 0, 1 and 4. So I have x, y, z. I got y and z. I am only interested in x value now. I did R1 minus R2. 1 minus 0 is 1. That's perfect. 1 minus 1 is 0. And I have 1 here. And 1 minus of minus 10. That is nothing but equal to 11. Now I want another 0 at A13. For that again what I will do? I will apply again transformation. I will say R1 is assigned R1 minus R3 now. Why I am doing that? Because I can do 1 minus 1 and I can get rid of the 0 whatever I have. So what it becomes now? I will have 0, 1, 0, minus 10, 0, 0, 1 and 4 as it is. When I do R1 minus R3, 1 minus 0 is 1, 0 minus 0 is 0, 1 minus 1 is 0, and I will have 11 minus 4 equal to 7. So you can see now 1, 0, 0, 7, 0, 1, 0 minus 10, 0, 0, 1, 4. That's nothing but x equal to 7, y equal to minus 10 and z equal to 4. Let's go back and check that. We'll just do a random check. 7 minus 10 and 4. 7 is x, y is minus 10, z is 4. Okay, here we go. First equation. X is 7. 7 plus 7 minus 10 plus 4. 7 minus 10. 7 minus 10 plus 4. 7 plus 4 is 11. 11 minus 10 is 1. Correct. 2 into x, that is 14. 2 into y, that is minus 20. 3 into z, that is 12. 14 plus 12 is 26. 26 minus 20 is 6. That's done. X is 7. 4y is minus 40. 9z is 36. 7 plus 36 is 43. 43 minus 40 is 3. So you can see the values solution of this simultaneous linear non-homogeneous equation are 7, minus 10 and 4. So how to do that? Again I repeat, only 3-4 steps. Very simple. What you have to do? First make A11 as 0. Now use that and make A21, A31 as 0. Now your transformation should be only between R2 and R3. Convert R2 and R3 accordingly to make A23 and A32 as 0. You can use R2 and R3. Using R3 transform R2 and using R2 transform R3. You do both of them. Now you go to R1. You apply R1 and R2, R1 and R3 to get your identity matrix, or make A11 as 1 first, then make A21, A31 as zeros. Once you get A21, A31 as zeros, focus on row 2 and row 3 only. Since you have 1 0 already out of the 3 elements in both the identity matrix second row and third row, you have 2 zeros. It's very easy to get the other 0 by applying transformation on the other row. So I can say I can get A23 as a 0 and A32 as 0. Once you get R2, R3 fixed, now you go to R1 and apply from convert A1 to A13 as zeros by leveraging A22 and A33 respectively. That's how you can get XYZ values. It's pretty simple. We'll solve some more problems as part of Gauss-Jatheen method in the next videos. Thanks for visiting. Bye for now. See you in the next session.